All right, we're back again, and I'm Mr. Chu, and I have Mr. Chang here. It's
Welcome, welcome.
gonna help
Or
us out
hello,
with.
rather. I guess I'm joining you. I'm your guest.
I don't know, whatever. Okay, yeah, it's Mr. Chang and Mr. Chu somehow. Okay, so you're gonna help us out with even and odd functions today.
Absolutely.
Okay, so I think from the last video, we saw that for an even function, it's going to be true that if you evaluate f of negative x, it's going to equal f of x.
Hmm.
And for an odd function, if you evaluate f of negative x, it's going to equal negative f of x,
Sure.
right? Okay.
Alrighty.
So I think we have three examples here. So we're going to check algebraically, right? We have no idea what these looks like. What
Mm.
these look like. Actually, we do. We cheated. We typed them in the decimals earlier.
Don't tell him that.
Okay. Well. Okay. Anyways. Okay. We'll look at them later in decimals. Okay. But let's check out the first one. Mr. Chang, I think I'll let you take it away with the first one.
Yeah. So the way I like to look at these is essentially there's three pieces. There's f of x normally. There's f of negative x, and then there's also negative f of x, and you just want to see which ones are equal to each other. So I'll start off with f of negative x in this case. So I'm replacing that x inside the parentheses there with just a negative x. So that would just mean instead of x to the fourth, now I have negative, oops, negative x, not squared, to the fourth minus 2 times negative x
Okay, so
squared.
it looks like you're taking the original function f of x
Mm-hmm.
and evaluating it for an input of negative x.
Right, yeah,
Right.
yeah,
Okay.
yeah.
All right.
So this one's nice in that we notice, hey, if whenever I'm raising anything to an even power, negatives end up being canceled out, turning essentially positive. And so if I have negative x to the fourth, that's just going to be positive x to the fourth. And same thing right here, this will just be x squared. And so I'm really just back to negative 2x squared. So f of x, sorry, f of negative x actually is equal to that. And hey, look at that. This actually is f of x.
Okay, so it looks like you could make a conclusion, right? So you just like proved
Mm-hmm.
f of there, like you might put therefore, right? So
Oh yeah,
there,
QED or the triple dots.
yeah. Triple dots, yeah,
I like the
triple
triple
dots.
dots.
Hey, that's like the
Uh,
Predators thing when like the Predators like hunting, right? Isn't that the laser thing that he has? Okay,
I
anyway.
think you might be right, actually. I
Yeah,
never thought
okay.
of that.
Yeah, that's the reticule that's on like when you play Black Ops. Anyways, okay. All right.
I
So
wouldn't know, Mr. Chu. I don't play video games.
okay, all right. Yeah, right. Okay. So therefore f of yeah, f of x, well, yeah, f of negative x is equal to f of x, right?
Yeah.
Yeah.
Okay, yeah. So I guess I'll just write it out. So since f of negative x equals f of x, this tells us that this function,
Yeah, function is even, right?
yeah, the function,
Even. Okay.
which is f of x, the function f of x is even.
All right. Cool. Thank you, Mr. Chang. So that takes
Yeah.
care of example number one.
Mm-hmm.
Uh,
I
so
guess we should also, sorry, Mr. Chu, I think we might also want to point out, because it's totally possible for a function to be both even and odd,
yeah, I guess it's
right?
true.
So I guess just to be, maybe we won't do this for the next two, but just to check this one. Let's check negative f of x here, which is going to be the original f of x. Oops. So that's x to the fourth minus 2x squared. And I like to just put parentheses around the whole thing and plop a negative sign in front. Excuse me.
Yeah.
So now when I distribute that negative sign, I will get just negative x to the fourth, now plus 2x squared. And that totally is not f of x.
Yeah, and that's an interesting thing that you break up. It is possible to have a function that's both even and odd. I don't think we're going to get into it right now, but if you might think about it, what is that? What's that function? Think about it. How is it possible
Mm-hmm.
for it to be both even and odd? Okay, we'll leave it at that.
Yeah, so since f of negative x is not equal to f of, wait, wait, no, sorry. This should be f of negative x, right?
Yeah, since f of negative x
There we go.
is not equal to negative f of x. Yeah, it starts getting, yeah, there you go.
Sometimes, folks, you just gotta say this. You gotta read it or say it to yourself. If it helps while you're doing your homework, just say it out loud. Help yourself out.
Yeah.
So since these are not equal, the function is not odd.
Yeah, not odd.
Is not odd.
Yeah, so in summary, f of x is even, right? It's even.
Mm-hmm.
Yeah, it's even.
Yeah, this one's even and only even. Okay, sorry about that.
All right, so I think we have a couple of more examples. I forgot to time us to see how long we're going. Okay, we've probably been going about 5 minutes or so, I'm guessing. Okay, so here we go. Second function.
I'm having a great time.
Oh, okay. Well, all right, let's keep going.
Yeah.
G of x, so you want to go ahead and check the other one? I guess we're going to do the same thing, right?
Mm-hmm. Yeah, sure. So let's check f of negative x, sorry, or g of negative x rather. G of negative x is going to be, let's see, negative x cubed minus negative x there.
And by the way, notice Mr. Chang's excellent use of parentheses when he's substituting stuff in, right? It's a quantity negative x cubed, right? That's why we had Mr. Chang here.
Yeah, I love parentheses. Some people say maybe they're a little extra. I say if it helps you, why not do it? Or why not use them, rather. So let's see, I've evaluated g of negative x, and quite clearly, I think we can see that that is not the same thing as the original function, g of x. So this one is not even, unfortunately, or fortunately, depends on what you're going for. And let's just double check negative now, sorry, now let's check negative g of x. And so I'll just plop that parentheses and that negative sign in front, right, like so. And when I distribute that, I will get negative g of x equal to negative x cubed plus x. Remember, so this is where, remember, it really helps to talk to yourself and remind yourself what needs to be equal to what to make it even or odd. And remember, we're checking to see, is this equal to g of negative x? This is how we check oddness of functions. And I believe if this is g of negative x, which is right here, I circle it on rainbow because I like rainbows. Those actually are the same, right? So that's going to be checked off. So I believe this function g of x, well, I'll keep it rainbow because why not, is actually odd.
I sure hope it's odd. We picked it because it's supposed to be odd.
I sure hope so.
If it doesn't turn out odd, we did it wrong. Okay, so yeah, so you check g of negative x.
Mm-hmm.
You found it's not even because it did not equal the original function.
Right.
Then you did confirm that it does equal to the negative of the original function, so it's odd.
Mm-hmm.
Okay,
right.
Cool. So we have an even function for f of x and an odd function for g of x. Okay, that leaves us with the last one, h of x. You want to go ahead and do that one too?
Yeah, for sure. So let's take a look at, well, I'll plug in negative x. So we'll do this one in change the color. So we'll do magenta or purplish color. So let's see, h of negative x here is going to be 2 divided by negative x plus 1. Oops. And nothing really to distribute or anything like so. So we'll just be at negative x plus 1, which is not the original function, unfortunately. So it's not, this right here tells us it is not even. And let's check negative h of x. So I'll plop the original function inside parentheses here, drop that negative sign in front. And when I push that negative sign through, I'll just get the negative version of that fraction. No matter where I put that negative sign, whether I put it on top or on the bottom, I don't think it's going to look like h of negative x, unfortunately. It's not equal to h of negative x. I do not know why I just decided to change colors there. All right. I think actually this, I could see how one might think that it is. Do you see what I'm kind of getting at, Mr. Chu?
So let's see. Yeah, I'm just trying to follow here. So you've just, okay, you first checked h of negative x at the top, and you found it's not equal to the original function.
Right.
So we've just determined it's not even.
Right.
Then you checked negative h of x to see what that was, and you ended up with, I'm looking over here, negative 2 over x plus 1. And you compared that to h of negative x just to see if they're equal.
Right.
And they're not.
They are not.
They're not, right? So it's not even, it's not odd. So it looks like that's the third case where it's neither, right? Neither?
Yeah, definitely a neither.
Okay.
I did just want to mention briefly how if I look at this fraction, you know, you could think of like a negative fraction as, so like I could do it like so. I could think of it as negative 2 over that. And I could also think of it as putting the negative sign on the bottom. And so if I do that, it looks like it is equal to the original function. But
yeah, you got to be careful there, right?
Just be careful, folks.
Yeah.
Because it would actually be negative that entire denominator.
Good old parentheses.
Yeah. Okay. So again, this is still not equal to h of negative x.
Yeah. All right. I think that's like all the algebraic stuff, right, Mr. Chang?
Yeah, for sure, for sure. But we did also just want to double check that we, with the graphs, that these actually are even, odd, neither.
Oh, okay, so we're going to go to Desmos now, right?
Yeah, so I have them. Here's handy dandy Desmos. If you can see here, hopefully I made it a little bigger. On the first graph here is our handy dandy f of x, which we said was even.
So it should be So it should be symmetric with the y-axis, right? Even.
Right. It should be mirrored this
way.
way.
Yeah. All right.
Which it totally looks like it is. Now we can see a couple of our local minima and a local maximum, and we can see that they get matched up. Cool. So that is indeed even. We want to check this one, which we said was odd, right? And this is where we can see we have that, oops, sorry for that. We have that symmetry about the origin, or rotational symmetry. I think we can kind of see that if I took this this right side swoop and rotate it 180 degrees, it would land on top of the other one.
Yeah, I never thought of using that rotational. Yeah, that's pretty good.
Okay. I guess it was also two reflections, maybe reflected this way and then that way.
Yeah.
I don't know. I just like to use I just like to find excuses to use my hands. And then the last one we said was neither, I believe, right? And so definitely not symmetric across the y-axis, and definitely not rotationally similar. Although it does look like it almost.
Yeah, it's kind of off, right? Because it's like shifted over to the left, so it's not.
It's been like pushed over to the left, unfortunately. If we could push it back to the right side, then maybe it would be. But all right,
that does it, huh?
Yeah, I think so.
All right, well, we'll wrap it up then, okay? Yeah, see everyone next time.
Thanks for watching, folks.
All right.
Hit that subscribe button.